Hello and welcome to this video on Mohr's method of precipitation titration. In this video, we will learn about the principle, procedure, and calculations of this titration method. Principle, procedure, calculations. We will also see some examples of how to use this method to determine the concentration of chloride ions in a solution. Mohr's method of precipitation titration is a technique to determine the concentration of chloride ions in a solution. It is based on the reaction between silver nitrate and chloride ions, which forms a white precipitate of silver chloride. The end point of the titration is indicated by the formation of a red-brown precipitate of silver chromate, which occurs when all the chloride ions are consumed and excess silver ions react with chromate ions. The chemical reactions involved in this titration are AgNO3 plus Cl AgCl plus NO3. The procedure of this titration is as follows. Prepare a standard solution of silver nitrate of known concentration. This will be the titrant. Prepare a solution of potassium chromate of known concentration. This will be the indicator. Take a sample of the solution containing chloride ions of unknown concentration. This will be the analyte. Transfer a measured volume of the analyte to a conical flask using a pipette. Add a few drops of the indicator to the analyte and mix well. The solution should have a yellow color. Fill a burette with the titrant and note the initial reading. Add the titrant to the analyte drop by drop, while stirring the flask constantly. Observe the color change of the solution. As the titrant is added, a white precipitate of silver chloride will form. The solution will remain yellow until the end point is reached. Stop the titration when the solution turns red-brown. This indicates that all the chloride ions have reacted and excess silver ions have formed a red-brown precipitate of silver chromate. Note the final reading of the burette and calculate the volume of the titrant used. To calculate the concentration of chloride ions in the analyte, we can use the following formula. C1V1 equals C2V2, where C1 is the concentration of the titrant in mol/L. V1 is the volume of the titrant used in liters. C2 is the concentration of the analyte in mol/L. V2 is the volume of the analyte taken in liters. Let's see an example of how to use this formula. 0.1 moles per liter. Suppose we have prepared a standard solution of silver nitrate with a concentration of 0.05 moles per liter. We have also prepared a solution of potassium chromate with a concentration of 0.05. We have filled a burette with the titrant and noted the initial reading as 0 milliliters. We have added the titrant to the analyte drop by drop, while stirring the flask constantly. We have observed the color change of the solution. As the titrant is added, a white precipitate of silver chloride forms. The solution remains yellow until the end point is reached. We have stopped the titration when the solution turns red-brown. 23.50 milliliters. We have noted the final reading of the burette as. From the table we have calculate the average volume. 1000. We have converted the volume of the titrant and the analyte from ml to L by dividing by 0.0235 L and we have obtained. We have substituted the values in the formula and solved for C2. We have obtained C1V1 equals C2V2. 0.1x 0.0235 equals C2x 0.025. C2 equals 0.1 by 0.0235, 0.025. 0.094 moles per liter C2 equals 0.094 moles per liter. Therefore, the concentration of chloride ions in the analyte is. This is how we can use Mohr's method of precipitation titration to determine the concentration of chloride ions in a solution. This method is simple, accurate, and reliable. However, it has some limitations, such as it can only be used for chloride ions, not for other halides or anions. It requires a neutral or slightly alkaline medium, as acidic medium will interfere with the indicator. It is affected by the presence of other ions that can form precipitates with silver or chromate ions, such as sulfide, carbonate, phosphate, etc. It is sensitive to light, temperature, and air, as silver chloride and silver chromate can decompose or oxidize. These are some of the points that you should keep in mind while performing this titration. I hope you have learned something new and useful from this video. Thank you for watching. Joyson Classes. We provide you with valuable and up-to-date knowledge about the pharmacy education. We create entertaining yet informative videos on topics such as chemistry of drugs, biochemical reaction, and much more. Hit that subscribe button and press the bell icon and join our mission to make understanding pharmacy easier for everyone. Like, share, and comment on our videos. We look forward to hearing from you.
Joyson Classes.
The best for best.